Types of numbers. We have natural or counting numbers, we have whole numbers, we have integers, we have even numbers, we have odd numbers, we have prime numbers, we have real numbers, imaginary numbers, complex numbers, rational numbers, and irrational numbers. Note that there are other types of numbers, but these are the common ones. This topic might seem less relevant to you, but it's actually very, very important in math. It's related to topics like sets, probability, and its application extends beyond that. It also runs from your very basic education down to your final year in the university and even beyond. So you should take this very serious. An example of this is shown in this Y pass question. Senior Secondary School 2023 Math Paper 2 Section B, question 6A. You have this term counting numbers under a probability question. And for this reason, this topic had to be treated. Another example is the fact that it has been noticed that some students still struggle with the fact that 1 is not a prime number. So this topic had to be treated to fix that issue. You might actually be very good with the topic sets and probability, but for the fact that you don't know or you still struggle with the fact that 1 is not a prime number, you might get a question wrong, even with your very good stand on the topic. Do you know prime numbers are very important in finding the LCM, the HCF, product of prime factors of numbers, and if well applied, it can be used to find the square root of numbers, and also what can be multiplied by a number to make it a perfect square. So these and many more are the importance of types of numbers, and some of its applications will be treated. Natural or counting numbers. The first on our list is natural or counting numbers, represented with the capital letter N. They are numbers that can be used for counting. They are all positive numbers from 1 to infinity. Examples are 1, 2, 3, 4, and so on. They don't include negative numbers like -1, -2, -3, and so on. They don't include zeros, they don't include decimals, neither do they include fractions. It's like this question, how many circles are below? You count in 1, 2, 3, 4, 5, 6, 7. Now there are 7 circles here. You don't count from 0, 1, 2, 3, and you don't count from -1, -2, hence the name counting numbers. So natural numbers start from 1 up to infinity, whole numbers. The next on our list is whole numbers. A whole number is any number from 0 up to infinity. They are similar to natural numbers or counting numbers, but the difference is that you have 0 included. You have it from 0, 1, 2, 3, 4, 5. Those are whole numbers. Note, you start from 0, unlike natural numbers where you start from 1. And similar to natural numbers, they don't include negative numbers, fractions, or decimals. Let's note that too. Integers. Next on the list is integers, represented with the letter Z. They are all positive and negative whole numbers, including 0. They don't include decimals or fractions. Unlike the other two, they include negative numbers. So we have -2, -1, 0, 1, 2, 3, 4, and so on. But they don't include fractions or decimals. Let's note that too. Even numbers. The next on our list are even numbers. They are all numbers that are multiples of 2, or that can be divided by 2 without a remainder. We have them as 2, 4, 6, 8, 10, 12, 14, 16, and so on. Here we can see our multiples of 2. You have 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, 2 times 5, 10. So we have our even numbers from the result of multiplying 2 by each of the digits. So we have 2, 4, 6, 8, 10, 12, 14. 2 times 8 is 16, and so on. So these are even numbers. Odd numbers. The next on the list are odd numbers. They are all numbers that cannot be divided by 2. Examples are 1, 3, 5, 7, 9, 11, 13, 15. You should note that. Prime numbers. And next is prime numbers. Best definition I've seen so far is this. It says, prime numbers are all numbers greater than 1 that cannot exactly be divided by any other whole number less than itself, and 1 without a remainder. Note, a whole number greater than 1. So 1 is not a prime number. 1 is not a prime number. Examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, Using this as an example, 1 is not a prime number, 2 is a prime number. No other number can cut 2 except 2 and 1 that is lower than 2. 3 is a prime number. Only 1 and itself can cut it without a remainder or divide it without a remainder. 4 is not a prime number because 2 can go in 4. That's 2. That's without a remainder. 5, only 1 can go in 5 of all these other numbers. Only 1 can go in 5. 6, 2 can go in 6 and 3 can go in 6. So it's not a prime number. Then 7, only 7 and 1 can go in itself of all other numbers. 8, 4 can divide 8. 2 can divide 8 and get a whole number for the result. 9 is not a prime number. 3 can go in 9. So 9 is not a prime number. And so on. So we know our prime numbers as 2, 3, 5, 7, 11, 13, 17, etc. Apart from being important in topics like probability and sets, prime numbers is also important in topics like LCM, HCF, product of prime numbers, and so on.